So in previous two, we understood about the pH sensor. We have recorded two different voltages or two different known pH buffer, right? Now, normally these, if you seen last video, pH sensor gives us the voltage, right? But actually we know that pH sensor used to measure the value of pH, but now we are getting voltage. So we have to have some relation between the voltage and pH, right? That is what we call 2-point calibration. So you can consider, or you can, imagine about the formula for meter to centimeter. So you know the relation, and that's why you are able to convert meter into centimeter. Same way, we are trying to establish some relation between the voltage and actual pH. That is what we are going to do in this video. So these two reading we have already measured, right? pH 4.0 and pH 9.18. And now we have these 2 points. And using these 2 points, we will going to write the formula now. So the problem is sensor output voltage. Now we need actual pH value, and that's why we are doing this 2-point calibration. So basically we are doing voltage to pH conversion only, right? Now what this 2-point calibration is, so let us say here 1 point and here 1 point, right? And now we have to 2 points. So basically we can draw a line which fitted through these 2 points. And since the sensor's output is in linear way means if at 4.0 pH buffer output voltage is 2.92, and if at 9.18 output voltage is 2.13, so the liquid which having pH between these two, then voltage must be between these two only, right? So basically we need a line which can best fit it through all these points. And once we have equation of line, you remember, then we can simply use that equation and provide the input voltage, and that line will give us the pH. So now we have 2 points. So basically these 2 points define the calibration line, right? So this I have already seen, right? Show you this line. Okay, now, so the main calculation is slope and offset, or you can say intercept. So to find the slope, what you can do, imagine this point as a, uh, you can say x1 y1 and x2 y2. You have to simply write y2 minus y1 or whatever, right? y1 minus y2 whereby x2 minus x1, right? And same way offset is equal to y1 minus slope into x1. And this is how you will have slope and offset, right? And this is the same formula which we have used in our code, right? And once you have this slope and intercept, we can simply put this in our code and convert this or write one equation. That equation will give us the actual pH value. So before understanding this, let us start understanding the coding, right? And here is our last display voltage function. So now this time, since we have recorded two different values, now let me comment out this and let me enable this function, right? Because in this video we will going to display actual pH value. Now let us see what this function is doing. And here remember we are passing two different arguments. One is volt at 4.0 pH and second is volt at 9.18 pH. Okay, so now let us understand this function. And here is the function you can see. So initially we are actually calculating slope. So this is the same equation which I have already explained you, right? This one slope. So this is the slope and this is the offset. Now once we have slope and offset available with us, we can simply use it in our equation, right? Now what I am doing here I am simply multiplying this with 100 because we want integer calculation, that's it. Okay, so later on you will see we will also divide this with 100, right, to get the actual value. But main core part of this function is this finding slope and offset, right? Now here we are converting this into integer, then here we are simply printing different values on LCD, sorry UART, and this is for LCD, right? So we are clearing out LCD. So you have to remember 01 means clearing the LCD, Then on first line, we will simply measure pH measurement. Second line this, and this is while one. So this is infinite loop. So again, we are using ADC channel 3. So whenever I will put sensor in any liquid, that sensor will generate or sensor will convert that output voltage equivalent to the input pH, right? And that voltage will recorded through this ADC channel 3. So here we are averaging out to reduce the noise or reduce the variation. After averaging out, we are simply converting this voltage into millivolt and whatever, right? And we are simply displaying that. And main part is this pH, right? So here you can see this is our offset, this is our input voltage, and this is our slope. So if you remember, I told you about one equation called y equal to mx plus c. So here x is our voltage, y is our pH, m is our slope. So you can see this is our slope, and v is the intercept. So you can see this is the intercept. So this is the actual equation. Y is equal to mx plus c, or m into voltage plus offset, right? Actually, this is c, right? And we are simply using this slope and intercept in this equation. And now once we have this equation ready with us, what we are doing, we are simply putting voltage. So this ADC channel will measure the voltage, and we are simply putting this voltage instead of this V. And now we have M, we know M, we know C. So this result in pH, and we are simply using this pH, right, in display. So we are just simply printing this pH as it is on LCD. Okay, and these are boundary condition. So in any product, even with because of noise or some configuration or connection, the pH value should not in negative. So that's why I just simply put two condition. If my pH is less than 0, so consider it as a 0, and if my pH value is greater than 14, so consider it as a 14. Now 0 is again for integer calculation. That's it. Okay, and this is the overall function. So now I'm enabling this function. So this function will give us the pH value. So simply I load this program, and once this program is loaded on the board, I can put my sensor in any liquid, and on LCD you will see we have pH value. Okay, so now I'm going to compile this code and load this code on board. So now next, see this setup. You can see our setup. So currently my probe is in 9.18 pH, you can see, and here is the display. So you can see it is giving 9 point something, right? 9.07, 9.11. So still some error is there, but it is, we can ignore this, right? Now I'm just changing this position from 9.18 to 4.0, and now let us check this. So now it is showing pH around 3.95, 98 something, right? Exactly 4. Okay, good. So now this is how you can calibrate this. Now let us measure the pH of RO water. So this is my RO water. Again I am cleaning my probe with the distilled water, and I am putting this in RO water. And now let us measure this. So it is around 7 or something, right? Let us wait for exact value, or you can say less changes in the output, right? And here you can see voltage is 2.44 and pH is around 7.08 or 7.30, right? It is still changing, but it is good, right? So for drinkable water it is under the limit, and this is from RO water. Now let us do one experiment. I'm just using a lemon and make this water acidic. So I'm just removing this probe, and this is real-time experiment I am doing. I don't know what will be the result, right? So let us use this lemon. I'm just making this water more and more acidic. See how, so you remember the reading, right? It is more than 7. And now let us remove this from distilled water and insert this, and now let us check the reading. And you can see the pH is very less, right? Previously it was around 7 point something, but now it is less than 3, right? So it's now acidic water because of the lemon. And you can also observe this on UART, right? Same reading. So this is how you can calibrate the pH sensor, and you can get the value for any water or any liquid. So this is what for today's video. I will put the circuit and code in the description of this video. So please, if you like my work, please like my YouTube video, subscribe my channel, share it with your friends. Till then, bye bye. Thanks a lot for watching this.